I worked in the Giovannone lab this summer, and I worked on the tomato because it is characterized well genetically and it grows relatively quickly in about 3 to 4 months. And in wild-type tomatoes, they contain the Rin gene, which is responsible for all typical ripening processes that occur, such as carotenoid accumulation, volatiles, texture, smell, all that good stuff that you see in a tomato in the supermarket. It's because of the Rin gene. And essentially, in the Rin mutant, all those aforementioned ripening processes are inhibited, and you're just left with a green, hard tomato. And essentially, my project is investigating what part of the chimeric Rin microcalyx gene causes that severe non-ripening phenotype exhibited in the Rin mutant. And I know you probably can't see very well, but on my poster, I have a little diagram of the gene, and you can see that the 8th exon of the Rin locus is deleted and the 1st exon of the macrocalyx locus is deleted. And this results in an unusual message that we see in the phenotype in the Rin mutant. In a previous research paper, it was suggested that the putative EAR domain, which is located in the 8th locus of the macrocalyx gene, is what is responsible for the severe phenotype exhibited. And I will be investigating whether that's true, and if it's not, what does cause the phenotype. So essentially, I ran a PCR test to amplify the CRISPR-Cas9 gene-edited fragments, and then I gel purified and sent it to Sanger sequencing, where I got the nucleotide sequences, and I also ran them through a program, and I got the putative protein of those sequences. In the macrocalyx EAR-11-13 line, it shows a single nucleotide deletion in the 8th exon of the gene, which is essentially only deleting the EAR domain. And if we go back to our previous hypothesis, if we delete the EAR domain, we should see full ripening revert because it's acting as the primary repressor, but we see the fruit remain yellow, which suggests that the previous hypothesis was incorrect. And if we go further in my results, we can see that in the microcalyx EAR 4-3 line and 7-5 line, that when we delete the EAR domain and a little bit more of the microcalyx gene, we see even more ripening return to the fruit. And furthermore, when we look at the microcalyx CRISPR-16 line, which targeted almost the entire microcalyx locus, we see full ripening return to the fruit, which further suggests that the entire microcalyx locus is responsible for the severe phenotype in the Rin mutant. It might be a little cheesy to say this, but probably all the great connections I made, and honestly the professional and non-professional ones.